So when we encounter a problem like number 1 here, which is like number 2 on your test, we're going to want to write a similarity statement, right, which consists of naming a triangle using the similarity figure and then naming the other triangle exactly how it corresponds to the first triangle. So you in your awesomeness can name the triangle whatever you want to name it. And I'm going to call this triangle 1, so we're going to look at this triangle first. I'm going to use triangle ARC, and you can use whatever triangle you want to, but I'm using ARC. So then your second triangle has to match up with the first one. So angle A goes with angle N, so here we have N. R has 2 arcs, which goes with O, and then of course C would go with W, so my triangle would be triangle ARC is similar to triangle NOW. Now from that, we can write an extended proportion. Okay, so we're going to write 3 equal ratios when we compare corresponding sides of each of your triangles. So we write down the ratios of the letters, right? This comes from your letters. The first 2 letters of your triangle match up with the first 2 letters of that triangle. Okay, and the second 2 letters and the second 2, and then the outside letters, they all match up. Okay, so that's what happens when we have similar triangles. You can write things in proportion, especially your side lengths. Okay, so let's move on here to number 3. So sorry my picture is crappy, but this is number 2. And we're looking at, this is the parallel proportions or the side splitter theorem. Right, so we're going to have a triangle nested within another triangle. There's the triangle on top, which is triangle AEF, right? So here are the 3 sides, A, E, and F of your smaller triangle. And then we have the triangle that it's within, okay, which is this triangle involving all the sides, right, where C is one of the sides. So we have these overlapping or nesting triangles. So let me quickly draw the triangles again. So when I break these apart and I unnest them, I have a triangle with side A, E, and F. And then here is my other triangle that matches up with it. Okay, so if I am looking for A over B, if I do A over B, that means I'm looking at my original picture, my nested triangles, and I'm comparing A to B. Okay, so this is the theorem that goes along with the parallel proportions theorem. And that says if I compare those 2 sides, I have to compare E and D. So this is E over D, right? I'm comparing similar sides, right? Corresponding parts. Because it got chopped right here. So I am comparing the parts of your choppedness. Now, A over E, there are a couple of different ways I can do A over E. Okay, so if I'm comparing A to E, I could also be comparing using the theorem B to D. So that is one way that I could do this. B to, sorry, that's not B. B to D, right? And that is the equivalent to what I just did here, right? These 2 are equivalents because their cross products are equal. If I look at B times A or D times A, right, I get the same thing here. So those 2 are equivalents because their cross products are equal. Now, what else does A over E relate to? So if I did A over E, looking at this triangle, A over E, okay, that could also be A plus B, right? This side, these 2 sides correspond over E plus D because these 2 sides correspond, right? Because I don't know what my other one is, I have 2 different proportions for A over E. I could either be using the parallel theorem proportion or I could be using my similar triangle proportion where I'm comparing corresponding sides of 2 different triangles. But there's really only one answer for the last one. If I compare E over F, E over F, I have to compare the whole entire side, right? This side goes with E, and that side goes with F. So I have a sum of E plus D over C. So depending on what proportions you're given, you're going to have a couple of different ratios that you can write. Okay, so be careful to make sure that you are using the one that they are asking for in your problem. Okay, let's scoot over here to one that we can't see yet. So let me pause. It just cut out, sorry. I'll just pick up here. So n over something, right? So I have n over something is in proportion to w over something. So hopefully you know if I go up the n side, I have to come down the m side. So n over m is in proportion to, if I go up the w side, I have to continue along that line. So I end up with v here. So once again, that was m over v is in proportion to n over w, or n over w equals n over m equals w over v, right? These are equivalent because when I cross multiply, I get the same answer. mw equals nv. So those are two equivalent equations for that problem. Okay, moving on to the right triangle similarity. Right? We can identify what side of what triangle we have. So it looks like I am looking at the medium triangle and the small triangle, right? That's what A, B, and C belong to the medium triangle, and A and C belong to the small triangle. So B is what side of what triangle? It looks like B is the long leg of the medium triangle, and C is the altitude. But if I'm talking about my medium triangle, this is the long side of my small triangle. So then what side is A? A is the short side of your small triangle. So I am looking for the short side of your medium triangle. And that's going to be letter C. So B over C equals C over A. So this is also your altitude proportion, which, as we talked about, is B over C, or leg over altitude. Leg B over altitude C is in proportion to altitude C over the rest of your leg. Okay, and that's what we talked about in class. It's on the poster. So on our next one, we have side E. So what side does side E go with? What triangle is what side of what triangle is E? It's the hypotenuse of your small triangle and the short side of your largest triangle. So it doesn't really matter which one you put where. So I'm just going to put the short of the long here and the hypotenuse of the small there. So I am looking for the short leg of my small triangle and also the hypotenuse of my large. So the hypotenuse of the large triangle is G plus F, or F plus G, whichever way you want to look at it, G plus F or F plus G. And then the short side of my small triangle is just F. Okay, so this is using the non-altitude. The hypotenuse over the leg equals the leg over the segment closest to the side we're trying to find. Okay, that's the non-altitude, or the hypotenuse, leg, and seg proportion from the poster in class. And lastly, J and K. J is what side of what triangle? The hypotenuse of the medium, which means K is the long leg of your medium. So I'm going to look for the hypotenuse of my large and the long of my large. So the hypotenuse of the largest triangle is K plus H, or H plus K, whichever way your brain thinks. And the long leg of your large triangle is J, right? And these are The same type of a proportion that we just had, something that does not involve the altitude. Very good job. Okay, and our last one, we have your bow tie or your, let's see, what is this called? Angle proportions theorem, I think. So let's look. X over n. I have x here over n there. Is in proportion to what other sides? X goes with P, right? Because you have to go down the same side, right? You got to continue on that same line. X goes with P, and N goes with Y. N goes with Y. So X over N equals P over Y. Okay, how about W over what equals X over P? All right, so we have X over P, and we have W over Z, right? W over Z. W and Z are your parallel sides. They're the ones that go together. Now our next one isn't even right. W over N, so let's erase this. W over N, let's make it true. W over N, Y over N goes with what? No, it doesn't, because Y doesn't go with X, does it?
Oh, N over.
It should say P over what? Right, because Y is from this triangle, P is from the right triangle also. So if we're going Y over N, that's in proportion to P over X. So there was a typo there, P over X. Y over N equals P over X. And then what over what equals W over N? Z goes with W and Y goes with N. So Z over Y is in proportion to W over N. Okay? So those are all of our proportions that we've talked about for the past couple of days. Okay? And you have questions like that where you have to fill in the blank on your test on Monday. So hopefully this is better and you feel more confident about your proportions.